All right, so what we're going to be working on today is section 1.2 functions. Okay, functions deal with domain and range. They deal with a lot of different things. How can you tell whether something is a function just based on the points that you're given and stuff like that? So we'll talk all about that. But we're going to basically just talk about functions. Okay, so let's start off with just the definition. Okay, so functions. Now, a function is a relation. Now, a relation can be described as just a set of points, okay? Just a lot of different points. So a function is a relation that assigns, so that means this relation has a specific, I guess you could say, direction to it. So that assigns one x value to exactly one y value. Okay, so it assigns one x value to exactly one y value. Okay, now one way that you can see this happening is through mapping. Okay, so I'm going to put right here, you can see it through mapping. Now I'm not sure if you guys remember doing mapping, or I'm not even sure if you've ever done a mapping. Does that sound familiar to anybody, those words, mappings? So a mapping is like this. If I give you some points, let's say 1, 2, 4, comma, -1, and let's say -5, comma, 3. And I ask you, is this a function? Okay, one way you can check is if you look, every x value goes to a y value only once, right? The number 1 only goes to 2, right? 1, 2, right? 1, 2. So 1 goes to 2, 4 goes to -1, -5 goes to 3. Notice 4 does not go, like 4 doesn't relate itself with a 2 here or with a 3 over here. It only relates with -1, right? So the x value of 4 only attaches itself to -1 from the y values. That's what we kind of want. We want it to be where it only attaches itself once. So here's a mapping. A mapping looks kind of like two eggs. And then what you do is you list your x values. Some people like to put them in numerical order. I really don't care, but those are all my x values, -5, 1, and 4. And then all my y values, -1, 2, and 3. And then I'm going to map them. Okay, I'm going to say, okay, -5 is related to 3. -5, 3 is a point, right? 4 is related to -1, and 1 is related to 2. So the question is, some people like to put x, y up here, so I'll just put it up there for you guys. The main question is, do you see any x value that has more than one arrow coming out of it? No, right? So that means that the x value is related to exactly one y value. Okay? A mapping like the following, let's say -2, 3, 1, 1, and -2, 4. If I do this mapping, so I'll put 2 of these things here. I'll write down my numbers. So this is -2 and 1. Those are my x values. Notice I know -2 comes out twice, but you don't have to write it twice. Okay, so -2 and 1 are my x values. And for the y values, I get 1, 3, and 4. Notice how there's more y values than x values? Sometimes that's a giveaway that this may not be a function, but just to kind of prove it, -2 relates to 3, 1 relates to 1, and then -2 relates to 4. Is there an x value that has more than one arrow coming out of it? Yeah, so that means that that x value is not related to exactly one y value. It actually is related to two y values. Okay, So this one over here, I would say that this is a function. Okay, this is not a function. So a mapping is a nice way to tell whether or not something is a function because you're actually able to map the points. Okay, problem is you're not always given a set of points. Okay, so there's other ways that you can check if something is a function. Okay, but we'll talk about that in a bit. Now, things that you do have to know. Okay, the word domain and range. Okay, so domain is the set of all x values. Set of all x values that a function can obtain. Now, if you're looking at a picture, you should ask yourself this: how far left and right does it go? Okay, so when you're looking at a graph, you're asking yourself, how far to the left does it go? What's the numerical value on the x-axis? How far left and how far right? Okay, and that's a way that you can find domain. Okay, this part right here is the domain of that function, your x values, right? That's our domain. Here's the domain for this function, or I guess not a function, for that relation. Okay, if something isn't a function, we call it a relation. So for that relation, the domain is right there circled or highlighted in yellow. Okay, now there's also the word range. So range is the set of all y values. The set of all y values that a function can obtain. Now, if you're looking at a graph, you ask yourself how low and how high does it go? Okay, so you're just going to look at the picture and say, what's the lowest it goes? What's the highest it goes? Sometimes it goes on to positive infinity, meaning it's going up all the way forever, right? Sometimes it only goes as low as -3, okay, on the y-axis. So our domain, I guess I can highlight this word domain in yellow to kind of help us out here. And then our range, I'll put it in blue here. This is our range. Okay, just the y values. All right, so let's do an example here, even though we kind of already did, but this is I guess a formal example. Example number 1 are these functions. So part A, make a quick table here. Here's my x and y. I need 1, 2, 5 spots. So 1, 2, 3, 4, 5. So put 2, 4, 3, 2, 1, 6, 0, 2, 1, 3. So that's one of them. And for part B, draw just a small graph, nothing big. Actually, let's see. This other one I messed up on the red dot. It should be here. Sorry. So I'll give you a moment just to kind of draw that in. So what do you guys think? Is a function? I see some of you guys saying no. What's wrong with it? Can you type the number that's wrong with it? Yeah, the 2, right? Notice it comes out twice on the x value. It can come out every single time on the y value. Like everything down here on the y value, I'm going to probably erase this right now, but everything in blue, if that was all a number 5, so it was 5, 5, 5, 5, 5, that doesn't matter in terms of functions. Okay, the y value can be whatever it wants to be. It's the x value that's being restricted. Okay, so the fact that there's two values of 2 on the x value makes it not a function. Okay, now what about part B? Is that a function? Well, there's a couple ways you can do this. You can write down all the points and check to see if any of the x values match. You could map them, write down all the points and map them. I see some of you guys saying yes, and it would be. You can map them. Or there's one more method. Does anybody remember that third method? It's kind of like a shortcut. It's a specific name. Maybe you can show me with like your pencil. Yeah, there you go. Vertical line test. Yeah, vertical line test, right? Basically says if you go to your graph and draw vertical lines at every point that you see, if that vertical line touches only one point on that graph, okay, every single time that you draw it, if it only touches one point, then it is a function. Now, if I want to make it not a function, all I got to do is maybe like put another point right there. Then now it's not a function because you can see that last vertical line is touching 2 points per line, right? So that would not be good. So that is a function the way it is. All right, so vertical line test basically says that if you draw a vertical line and it only touches 1 point of the graph per line, okay, because I've had students say, well, I drew a bunch of vertical lines and it touched 5 points. Well, yeah, but individually it touched one at a time, right? So as long as it does that, then you have a function. So, all right. So that's good. We got that here. I'm just checking time real quick. All right. So on the homework, they're going to ask you which of these equations represents y as a function of x. And they give, we're going to do 2 of them here. We'll do x squared plus y equals to 1, and b negative x plus y squared equals to 1. So a lot of times people say, well, none of these represent y as a function of x. But that's actually not true. You try to solve for y, and if you can solve for y, then that means that y is being represented as a function of x. So, for example, the first one, I can just get the x squared and throw it to the other side. So y is equal to negative x squared plus 1. Right? So this one would be a yes, right? This one represents it as the letter y as a function of x. Okay, how do I know it's a function? If I were to graph this, and you guys can use, you don't have to, draw it on a piece of paper or anything. But if I were to graph this, this function looks like this. if I do a vertical line test, it'll only touch one point of that graph every single time. So that's good, right? So usually if you can rewrite it like that, it's going to work out. Now let's look at the other one. If I move the x over, I get y squared equal to x plus 1, but I got to solve for y. That means I got to take a square root of both sides, right? I got to do square root of both sides here. So I get y equal to plus or minus the square root of x plus 1. So a lot of times people will say, well, look, I did it. I was able to solve for y, so it must be a function of x, right? But if we draw a picture of this, okay, in order to draw a picture of this, you need to take both solutions, okay? You got to take the solution of, whoa, hold on, messed that up. Give me a second. Where's this thing here? Why is it doing that? Let me try that one more time. And it's weird because it's not erasing that little piece. Let me get rid of that. Maybe I'm accidentally touching the bar too much. We'll see. All right. So the graph of this looks a little bit more like this. Actually, I underdrew that bottom line, but that's the idea. Okay. So notice if I do vertical line tests, touches twice, touches twice, touches twice, touches twice, right? This fails. So this would be a no. Okay. So that doesn't work. Now, aside from that, they want you guys to know how to do function notation. Okay, function notation looks like this. So this is y equals to f of x. And then they want you to be able to like solve for stuff. So in other words, they might say like if f of x is equal to x3, find f of negative 1, f of 2, and f of 0. All right, so they'll ask you to do stuff like that. Okay, so if that's what we're going to have to do, then we just have to plug in the number. I don't know if you guys remember doing this. I hope you do. But you just basically say f of negative 1 is equal to negative 1 plus 3, which is 2. F of 2 is equal to 2 plus 3, that's 5. F of 0, you're just plugging it into the main equation, right? That's 0 plus 3, and that's equal to 3. So that should be relatively simple, I hope. Nothing too confusing. Nothing you really have to worry about too much. Okay. So I'm trying to think here. Let's talk about the domain of a function really quick. And I may have to kind of continue this the next day. We'll see, because I think we're out of here at 45. I got 12 minutes. I don't think there's a way I can do piecewise functions. So we're going to talk about the domain, how to find the domain of a function. If it's like an equation that they give you, all right, it's actually pretty easy. But well, actually, let me restate that. It's pretty easy if you know what the functions kind of look like. So sometimes it might be good to get these things graphed. Okay, if you already know them in your head, it's a lot easier too. But you know, we'll kind of do this slowly here. So the domain of a function. I'm noticing my pen is lagging a little bit. And I'm wondering if because I'm recording this thing as I'm broadcasting it. I'm not really sure. But I just noticed that there's a little bit of lag. I think that's why there was a little problem when I would do like the graph. Then you get that weird little blue line showing up. I'm not sure. So we'll see. Okay. So what I want to do is I want to write the domain of each function. Okay, let's find the domain of each function. So here's the first function. So f of x is equal to 1 over x. Okay, for the second one, we'll write f of x is equal to 1 over x squared minus 4. And for the last one, this is what we do, and then we'll just call it at that point. All right, guys, so I decided to kind of re-record this last part here, the domain of a function. So in order to figure out the domain of a function, what you want to do is find out where the function does not exist. And once you know where it doesn't exist, then you can write out its domain. So for example, this very first function here, f of x equals to 1 over x, the only thing that we're going to focus on here, since it's a fraction, is the denominator. We know that if x is equal to 0, then we're dividing by 0, so that would be a bad thing. So the domain is all numbers except for x equal to 0. So x cannot equal to 0. So you're going to say all real numbers. Let me write this out here. All real numbers such that x cannot equal to 0. And that's your domain. Now for the next one, we look at the fraction again and we say, okay, we got to solve for this denominator. So what makes that 0? So that we would say x squared equals to 4, so x equal to plus or minus 2, right? If x is equal to plus or minus 2, then we get a 0 in the denominator. Well, we don't want that, right? X cannot be those numbers. So we're going to say all real numbers. All real numbers such that x is not equal to plus or minus 2. And that would be that answer. Okay, and for the last one, we see it's not a fraction. It's actually a square root, and based on the information we know about square roots, the number inside of a square root can be anything except for a negative number. So x can't be negative, so that means x must be greater than 0, right? Well, I guess greater than or equal to 0, right? So we're going to say it's all real numbers such that x is greater than or equal to 0. And we'll put that here. And that's our solution. Okay, so hopefully that kind of helps with the end of the lesson. I know it kind of went a little weird with all the lagging that was going on, but I guess I'm not going to be able to record videos because that happened. So anyway, there is the end of the lesson for today.